Welcome to another practical physics walkthrough. Today we're going to be looking at Boyle's law, one of the upper sixth experiments. So the relationship that we're going to be investigating is between pressure and volume, and as part of it you're going to actually be trying to calculate a value for the molar gas constant. It's self-contained and you need no other equipment at all other than a thermometer, and you'll also need to refer to the sheet for the various constants you're going to use. So this is the equipment you're going to use, and over here we've got a little dial that you twizzle in and out, and that moves this plunger in or out, and this air volume here, which is sealed, will be compressed or decompressed. Got a nice little pressure gauge here, and crucially this is the valve that you will need to close in order to stop that air escaping from the cylinder. So the first thing you'll need to do with the valve open is just make sure, and this can be quite stiff, that you've got this plunger opened out. Oh my goodness, that is stiff. To exactly 10 on this scale. This is a centimetres cube scale, it's a volume scale. And you'll want to get your eye absolutely over it. And just make sure we're focused on this. And the way you do this is make sure that you can only just see this face. So I just need to open that out a smidge more. Right, that's bang on. Then you close this valve, and this is now a fixed air volume inside there. Sorry, it's not a fixed air volume, it's a fixed number of moles inside there. It's a fixed amount of air. The air volume can be changed by changing this, by turning this screw. So if I now compress this, what you will notice is that I could just do it to 9.5, and that's gone up a smidge. Go to 9. I could read off the value from the pressure gauge. And as you can see, as I can compress this up, you watch the pressure gauge increasing. So as the volume decreases, the pressure increases. Do not take this past 3.4 on here. So there's absolutely no need to go past 3. You'll be able to get 8 good readings. And obviously as it gets more and more and more compressed, okay, I make that 3.4, and rather neatly, that is almost bang on 3 there. Do not be tempted to release that. Okay. Apart from anything else, you'll have to completely start your experiment over again. It's vital that we keep a fixed number of moles of gas in there. Now, obviously, as you decompress this, you could be retaking your readings. So as I open this out to 4, I could retake my reading. So this will be slightly quicker for you to take repeat readings. And it will be vital for you to take repeat readings. And unsurprisingly, it's a bit easier for me to open it up. But of course, I know what you're thinking. If this relationship holds, it shouldn't matter if it's for atmospheric pressures greater than 1 atmosphere or less than 1 atmosphere. So in actual fact, what I can do is continue to, I'll probably speed this up, continue to unscrew this past the 10 centimetres cubed. It starts to get hard again, I'm having to really give it a bit of welly, but you can see that the pressure gauge is starting to decrease. So let's do this so I can do this a little bit more clearly, and hopefully you can see that as I'm retracting the plunger, by continuing to turn it, you can see the pressure gauge going down. And of course you could take this all the way out to the 27 centimetres cubed mark, but I won't bother for now. Clearly that is a quick experiment. You're going to want to get 3 repeats done. If I were you, I wouldn't leave this in a pressurised state for any period of time. I'd take my readings and then return it back to 10 centimetres cubed, because there is a chance, it's a pretty good piece of kit actually, but there's obviously a chance there'll be a little bit of leakage of air, particulate pressures that are greatly different to atmospheric pressure. And if you do have a little bit of leakage, that will mean the number of moles changes within this cylinder and your experiment is. When you've finished the experiment, return it to the 10 centimetre mark and you can open up the valve and return it to the prep room. Right, I hope that was useful and that it's given you a little overview about how to conduct this experiment. I don't intend to go over the minutiae of the analysis, but of course you'll be plotting a nice graph and you should get a straight line, and if you follow the instructions from that from the worksheet, you should be able to get a reasonable value for the molar gas constant.